What is a submersible pump and how it works? The submersible pump is a particular type of centrifugal pump used to move fluids from one point to another or to favor their ascent to the surface. This hydraulic device can be used, for example, to empty a flooded area, but also to empty or fill a swimming pool or recover and bring to the surface the water contained in a well. Modern centrifugal pumps represent both in domestic and industrial environments, valid solutions for moving a quantity of liquids in a given period of time. This ability can vary depending on the brand and the pumping power parameters. It's therefore very important to choose the type of submersible pump depending on the various use contexts, since a certain pump model could serve a purpose but be completely useless for a different one. For this reason, JAES is able to provide the best advice on choosing the most suitable immersion pump thanks to the wide range of models available in its online catalog. Immersion pumps are very efficient. They are self-priming, but above all, they are not subject to cavitation. That is to say, they do not create steam bubbles inside them, which could compromise their functioning. As in the case of the centrifugal pump, the immersion pump is also equipped with impellers, which pushes the liquid outwards thanks to their blades, which create the necessary centrifugal force to increase the speed of the liquid and thus create the right pressure within the pump body. Usually, the submersible pumps are equipped with backward curved impellers. In this model, an induction motor controls the rotation of a single shaft, to which many other impellers are connected. The fluid flows through the eye of the impeller. That's because the rotating impeller imparts a centrifugal force on the fluid in between the impeller blades. This centrifugal force pushes the fluid radially outward, leaving an empty void at the center. This void translates to low pressure at the eye of the impeller, which the surrounding fluid tries to equalize by rushing into that space. Now, the outgoing fluid will have to flow efficiently through the second impeller. For this reason, a diffuser is used to create an axial flow motion, which is the movement of the fluid in an up and down cyclic pattern. The diffuser makes the fluid ready to flow into the next impeller by deflecting its inlet flow. Thanks to a series of impellers and diffusers connected one to each other through the shaft, the fluid in question is able to multiply its pressure at each step. This is why submersible pumps usually have a very high pressure head. A non-slam check valve placed at the end of the series of impellers and diffusers collects the pumped fluid, thus avoiding the so-called hydraulic shock. Hydraulic shock, or water hammer, occurs when a fluid in motion is suddenly forced to stop or change its direction. This phenomenon commonly occurs when a valve closes suddenly at an end of a pipeline system and a pressure wave propagates in the pipe. The non-slam check valve helps to reduce this hydraulic phenomenon, which is widespread during high-altitude pumping. As we already said, an induction motor provides the prime mover of the submersible pump by transferring the rotary motion through the shaft and then to the series of impellers. Inside the induction motor, the stator provides electricity, which can be single-phase or three-phase, while a water or oil cooling system provides to lower the temperature, since these types of engines produce a lot of heat during their operation. A small impeller placed at the bottom of the engine ensures a continuous circular flow of the coolant. The continuous flow of coolant inside the engine prevents the motor from overheating. Submersible pumps are self-priming, which means that they are completely immersed in the fluid, which they are going to pump. Another positive feature of this type of pump is its ability to avoid cavitation, a phenomenon in which rapid changes of pressure in a liquid lead to the formation of small, vapor-filled cavities in places where the pressure is relatively low. Being completely immersed, the submersible pump pushes the fluid instead of pulling it. This helps to reduce the possibility of having a negative head pressure value, and consequentially to avoid cavitation. Thanks to their flow rate characteristics, the high head pressure, and the advantage of being completely immersed in the fluid, submersible pumps are ideal tools for firefighting, drilling wells, and oil extraction. They represent one of the most versatile and adaptable artificial lift methods, useful in many oil production plants where a reservoir no longer has sufficient energy to naturally produce at economic rates or to boost early production to improve financial performance. The absence of narrow flow regions in the impeller and diffuser sections makes the submersible pump the ideal choice for lifting highly viscous fluids and wastewater pumping. Finally, if you found this video useful, let us know by leaving a comment and subscribing to our YouTube channel to stay tuned on the latest release of new videos. Thanks for watching.